John, tell us about Alphabot and why it is so well suited to automate a supermarket. Why is it so much more capable than traditional fixed automation like shuttles, which have been around for 20 years? What is it about Alphabot that's better?
Well, from the very beginning, in my earliest conceptions of a solution, of a mobile robotic solution, I concluded that we want the mobile robot to be the only moving part, but it has to be able to move vertically. And so I was developing or inventing Alphabot at almost exactly the same time that Mick Mounts was inventing Kiva. So Kiva was really the very first breakthrough in the use of mobile robots to automate each picking successfully. And we both had a very similar conception of the robot being the only moving part, of doing both storage and retrieval and transport to the workstations, and actually moving the goods through the workstation and presenting to the picker. So, but Mounts' solution was very different and not very space efficient. My solution, Alphabot, had to be much more space efficient, and from the very beginning, I realized that the robot had to move vertically. So in my earliest conceptions, I had it moving up long ramps that would have been very impracticable and not a very good solution. But that was the vision that I had from the very beginning of a single moving part robot that could have random access to all storage locations, all workstations. And at the time that I started working on it, there were no shuttles. There was only cranes and conveyors, and the shuttles emerged not long after I started working on it, a couple of years later, and that was a mobile robotic solution that was basically an adaptation of the crane solution. And the problem with that solution is that the throughput assets, the throughput components, the mobile robots, the lifts, were dedicated to the storage assets. So every aisle had its own fleet of robots and lifts that would handle the storage and retrieval in and out of that aisle, and then conveyors would move the goods to the workstations and back. The problem with that architecture is that captivity makes for significant inefficiencies in capital. You can't scale throughput and storage independently, and so there's going to be an imbalance of either throughput assets or storage assets, and it's a lot of single points of failure, because in a typical round trip, in a single round trip from storage to workstation and back, a tote might be touched by 40 or 50 different mechanisms, including because every segment of conveyor is a mechanism. And in our system, it's only one. So if the robot is the only moving part, does storage, retrieval, and transport, and workstation presentation, then there's an enormous simplification that will yield a much more reliable robot. And the reason that's so important is that in the NovaStore application, we have to have extremely high reliability. We cannot disappoint customers by failing to give them the order that they just placed in the store. And so we have to have a system that works almost all the time. And so that the ability of our solution to replace not just the linear robots, not just the mobile robots, but the lifts, the conveyors, the transfers, the workstation transfers and machines, all of that, it goes away and you only have one moving part. So it's an enormously more elegant, capital efficient, and scalable technology than shuttles, and reliable technology than shuttles.